Hello and welcome guys to EduCeption. Today we begin with the chapter circles. Now the complete chapter of circles will be divided into 4 or 5 videos. Over those videos we are going to discuss the theorems and understand them, and we will also solve a lot of sums on circles. So watch all these videos and I hope you understand the chapter easily. This video is the first part, and over here we are going to discuss 3 theorems based on the angle properties of circles. Watch this video till the end, and if you like it, do hit the thumbs up button, share this video with your friends and subscribe to EduCeption if you haven't. Also press the bell icon to get notified of all our videos. Without further ado, let's begin. Circles. Before beginning with the theorems, let's brush up on a few basic things about circles. We all know that this is a circle and this point over here is the center of the circle. We call it O. Then comes radius. What is the radius? The length from the center of the circle to the circumference is called the radius. The radius of a circle is fixed and constant. Okay? Then comes chord. What is a chord? A straight line joining any 2 points on a circle is called a chord. Say we have the point A and the point B. A straight line joining AB is called a chord. Say we have a point X over here and a point Y over here. The straight line joining point XY is also a chord. Okay? Now a chord which passes through the center of the circle is the diameter. Say we have a chord which passes through the center of the circle, say PQ. So PQ is the diameter. So remember this, a chord which passes through the center of a circle is the diameter. I'll write it down. So PQ is the diameter. And we all know that diameter is twice the radius. Okay, so keep it in mind. Then comes arc. What is an arc? The length from A to B on the circumference is called an arc. So basically this length from A to B is called an arc. Okay. Now you can also take the length like this. So basically the smaller one becomes the minor arc and the longer one becomes the major arc, and an arc is represented like this. So arc AB. Okay. Then comes segment. What is segment? The region enclosed by a chord and an arc is a segment. So basically this region enclosed by the chord and the arc is a segment. Okay. Now that we are done with all this, we will move on to the theorems. Let's begin with the first theorem. The angle subtended by an arc of a circle at center is double the angle subtended by it at any point on the remaining part of the circle. What does this mean? Say we have a circle over here and an arc AB. Now the arc AB subtends an angle at the center O, and the arc AB subtends an angle on the circumference at C. This theorem says that the angle subtended at the center will be double the angle subtended at the circumference. That basically means that angle AOB will be twice angle ACB. And this point C can be anywhere in the circle except this arc AB. Say it can be here also. So for this also, angle AOB, the angle subtended at the center, will be equal to twice the angle subtended at the circumference, which is angle ADB. Okay. Now that means if this is X degree and this is Y degree, then X degree will be twice Y degree. Let me give you an example now. Say this angle over here is 30 degree, then the angle subtended on the center will be twice of 30, which is 60 degree. Okay, easy to understand. Now we will move on to the next theorem. Moving on to the second theorem. Angles in the same segment of a circle are equal. What does this mean? Say we have a circle and an arc AB. Now this arc AB subtends some angle on the circumference at C over here and at D over here. This theorem says that angle ACB will be equal to angle ADB. Let me write it down. So angle ACB will be equal to angle ADB. Let me clarify it a bit more. We have the arc AB. Let me join it with a chord. So we get the chord. Now we get two segments of the circle, a smaller one and a bigger one. The smaller one is called the minor segment and the bigger one is called the major segment. We can see that angle ACB and angle ADB are in the same segment, and the theorem says the angles in the same segment of a circle are equal. That means angle ACB will be equal to angle ADB. Okay. Now as a matter of fact, if you take any angle in this segment, that will be equal to angle ACB and angle ADB. Say I take this angle and I take this angle. I'll call it M and I'll call it N. So both these angles will be equal to angle AMB and angle ANB. Okay? Easy to understand? Now we will move on to the next theorem. Moving on to the next theorem. Angle in a semicircle is right angle. It is very simple. We have a circle over here and AB is the diameter of the circle. That means AB divides the circle into two semicircles, one here and one here, and any angle in a semicircle is 90 degree. That means over here angle ACB will be 90 degree, as simple as that. So angle ACB is equal to 90 degree. Now in a semicircle, if we take any angle, the angle will be 90 degree. Say if we take an angle like this will be 90 degree. Even if we take an angle like this will also be 90 degree. Okay, so remember this, angle in a semicircle is right angle. Okay, now that we have covered all the three theorems based on the angle properties of circles, we will move on to the sums. Before beginning with the sums, let me tell you a couple of things. Firstly, whenever you face a question on circles, look at the figure properly and try to determine all the theorems that you can apply on the figure. If you determine the theorems properly and apply them properly, you will definitely get your answer. Secondly, whenever you use a theorem, write the theorem there. If you miss to write the theorem, you will definitely lose marks. So keep these things in mind. Now we have the first question. Let's solve it. Question number 1. In the adjoining figure, O is the center of the circle and angle PBA is equal to 45 degree. You have to calculate the value of angle PQB. This is the given figure. O is the center of the circle. Angle PBA is given 45 degree. We have to calculate angle PQB. Okay. Now, as AB is passing through the center of the circle, AB is the diameter. That means it divides the circle into two semicircles, this one and this one. And the third theorem that we studied today was angles in a semicircle are right angle. That means we have an angle over here in a semicircle, which is angle APB. So angle APB will be 90 degree. 90 degree. Let me write it down that angle APB is equal to 90 degree. And beside it, I will write the theorem that I have used. That is, angle in a semicircle is right angle. Okay. Now in the triangle ABP, we know two angles, 90 degree and 45 degree. So we can easily calculate the third angle, as we know that the sum of three angles of a triangle is 180 degree. So we can easily calculate angle PAB. Let's do that. So in triangle ABP, angle PAB plus angle APB plus angle PBA is equal to 180 degree, and beside it I will write that sum of angles of a triangle is 180 degree. Okay, so therefore angle PAB plus 90 degree plus 45 degree is equal to 180 degree. Therefore angle PAB is equal to 180 degree minus 90 degree minus 45 degree. Therefore angle PAB is equal to 45 degree. So we calculated angle PAB as 45 degree. So PAB is equal to 45 degree. Now we have to ultimately calculate angle PQB. We can see that PB is an arc of the circle and PB subtends two angles on the circumference, one at A and one at Q. So we have angle PAB and angle PQB. The second theorem that we studied today was angles in the same segment are equal. So we have the same segment over here. So angles in the same segment will be equal. So PAB will be equal to angle PQB. So we get the answer. Let me write it down, that angle PQB is equal to angle PAB. Therefore angle PQB is equal to 45 degree. We get the answer, and beside it I will write the theorem that I have used, which is angles in the same segment of a circle are equal. So done. So basically when you face a question of circle, try to determine the theorems and apply them properly. You will definitely get the answer. Okay. Now we will move on to the next sum. Moving on to sum number 2. In the adjoining figure, AB is the diameter of the circle with center O. If angle BOC is equal to 120 degree, we have to find the measure of angle ADC. This is the given figure. AB is the diameter and angle BOC is given 120 degree. We have to find angle ADC. So let's begin. We can see that AB is the diameter of the circle. That means it is a straight line, and the angles on a straight line add up to be 180 degree. So this angle over here, that means angle BOC, plus this angle over here, that means angle AOC, will be 180 degree. Let me write it down. So angle AOC plus angle BOC will be 180 degree. I'll write the reason that AB is a straight line. Okay. Therefore angle AOC plus 120 degree is equal to 180 degree. Therefore angle AOC is equal to 180 degree minus 120 degree. Therefore angle AOC is equal to 60 degree. So we get angle AOC is equal to 60 degree. So this over here is 60 degree. Now we can see that AC is an arc. It subtends an angle on the center O and it subtends an angle on the circumference at D. The first theorem that we studied today was the angle subtended by an arc at the center is double the angle subtended by it on the circumference. That means this angle over here will be double the angle subtended on the circumference. So basically angle AOC will be double the angle ADC. Let's write it down. angle AOC will be double angle ADC. We have to find angle ADC. We already know angle AOC, so we can calculate it. So therefore angle ADC will be half of angle AOC. Therefore angle ADC is equal to half into 60 degree. So angle ADC will be 30 degree. The answer. So angle ADC is equal to 30 degree. And beside this, I will have to write the theorem that I applied, that the angle subtended by an arc at the center will be double the angle subtended by it on the circumference. Okay. Now we will move on to the next sum. Moving on to sum number 3. In the adjoining figure, AD is the diameter of a circle with center O. If AD is parallel to BC and angle CBD is equal to 32 degree, you have to find number 1 angle OBD, number 2 angle AOB, and number 3 angle BED. This is the given figure. AD is the diameter of the circle and AD is parallel to BC. Angle CBD is given, which is 32 degree. So let's begin. First of all, we have to calculate angle OBD. We know that BC is parallel to AD and angle CBD is 32 degree. We know the alternate angle of a line joining two parallel lines are equal. So we can see over here that we have two parallel lines AD and BC and a straight line joining them. So the alternate angle will be equal. So if this is 32 degree, this will also be 32 degree. So we get angle ADB is equal to angle CBD is equal to 32 degree. And I'll write over here that the alternate angles of a straight line joining two parallel lines are equal. Now that we get that angle ADB is 32 degree, we can see that OB is the radius of the circle and OD is also the radius of the circle. So triangle BOD is an isosceles triangle, and for an isosceles triangle, the angle of the same side will be equal. So if this is 32 degree, this angle will also be 32 degree. So we get angle OBD is equal to angle ODB is equal to 32 degree. And for this, I'll write the angle on the same side of an isosceles triangle are equal. So I get the first answer, that angle OBD is equal to 32 degree. The second one, we have to calculate angle AOB. Let's check it out. Angle AOB is this angle. So we can see that AB is an arc and AB subtends an angle at the center O and AB subtends an angle at the circumference at D. The first theorem that we studied today, the angle subtended by an arc at the center is double the angle subtended by it on the circumference. So angle AOB will be double angle ADB. Let's do that. So angle AOB is double angle ADB. Therefore angle AOB is equal to 2 into 32 degree. So angle AOB is equal to 64 degree. So we get our second answer. In the third one, we have to calculate angle BED. Let's check it out. Angle BED. Now AD is the diameter of the circle. That means it is dividing the circle into two semicircles. And we studied that angle in a semicircle is right angle. We can see that angle ABD is an angle in the semicircle, so it will be 90 degree. So angle ABD is equal to 90 degree. Let me write it down. Angle ABD is equal to 90 degree. And beside it, I will write that the angle in a semicircle is right angle. Okay. Now that we have got angle ABD and we know angle ADB, we can calculate angle DAB. because in the triangle ABD, the sum of all three angles is equal to 180 degree. So in triangle ADB, angle DAB plus angle ABD plus angle ADB is equal to 180 degree. Beside it I will write the sum of angles in a triangle is 180 degree. So I get angle DAB plus angle ABD, that's 90 degree, plus angle ADB, that's 32 degree, is equal to 180 degree. So I get angle DAB plus 90 plus 32, that's 122 degree, is equal to 180 degree. So angle DAB is equal to 180 degree minus 122 degree, and this will come out to be 58 degree. So I get angle DAB is equal to 58 degree, that is DAB is equal to 58 degree. Now BD is an arc and BD subtends two angles on the circumference, one at A and one at E. Now the second theorem that we studied was the angle in the same segment are equal. So angle BAD will be equal to angle BED. So if this is 58 degree, this will also be 58 degree. So I'll write angle BED is equal to angle DAB is equal to 58 degree. And beside it I'll write angle in the same segment are equal. So we get our third answer also, that angle BED is equal to 58 degree. So this sum at last comes to an end. Now after ending this sum, I will end this video over here. In the next video, we will begin with the cyclic properties of circles. So do watch that video. Until then, this is Rishi on behalf of EduCeption signing off.